So I'm going to call this 2.4 polygons with inscribed shapes. These are a lot of fun if you practice. Okay. Often you will be given a polygon with diagonals inside. These produce isosceles triangles, isosceles trapezoids, and isosceles pentagons. Sorry, that says isosceles pentagons, trust me. Those are the three that we're going to study. You can go, it goes on, but we'll just stop at isosceles pentagons. So I'll just really quickly use my notebook software here. I'll come back to the notes, so don't panic if I cover this up. So let's just keep it at 5, for example. No, let's go 8. So this is an octagon here. So you'll often be given an octagon, which we now know how to find the interior angles, right? We know how to find the exterior, the central, all of that stuff. What sometimes happens is they make a diagonal like this, and so you have your isosceles triangle up there. How do we know it's isosceles? Because this is a regular octagon, so that means that this side and this side, like they're all the same, right? But if we hone into this triangle, you actually have an isosceles triangle there. Does that make sense? You could cut here like that. And what does this look like? A trapezoid, right? And all of these sides will be the same. Okay. And where's your pentagon? Like, without making it too messy, I'm just going to move this one over 1. Because now it's 1, 2, 3, 4, 5, right? It's not a regular pentagon, it's an isosceles. So you actually have an isosceles pentagon, depending on how the diagonal goes. Okay, so that's what I mean by you will have a polygon with diagonals inside. Okay, and we'll sketch some so you can have an idea. And then we're going to go to our booklets because I printed some already, so we don't have to figure out how to sketch these things because it gets complicated. All right, so just a couple of things, a reminder, right? If you have an isosceles triangle, and I'll make 3 columns here, by the way, with some calculations, so I kind of go over a bit to the left. So isosceles triangle, these 2 sides are the same. So these 2 angles, which I'm going to refer to as B, are the same. And we call the one at the top there A, right? So how would we find B knowing what A is? It would be 180 minus 1 times A, and I do this for a reason. It's written like this, divided by 2. And if you have a different color, I will add the invisible brackets because students forget those. So if we wanted to find B, we would just go 180 minus the one angle at the top that we have, and we divide that by 2 because you're splitting that difference in half. Okay. And then we have split this here. Isosceles trapezoid. We actually have, it looks like this. It's like a cut-off triangle, right? A triangle where you cut off the top, you truncate it. So all these are the same. And we call those A at the top there. And the base will be B as well, so that we keep it consistent. To find that angle B, given like these two will be the same because of the sides here. What do all angles in a four-sided shape always add up to? 360, all right. So we would have to take 360 in this case and subtract not just 1 times A, but 2 times A, correct? There are 2 A's up here. And we would have to divide that by 2 to find out what those are. Okay. And last but not least, isosceles pentagon. This one is a little tricky to graph, so let's make a bit of a roof like this, and then we'll go in a bit like that and make the base the longest here. Here we have A, 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 and we have B and B. What do the angles in a five-sided shape always add up to? 720? Not quite. There's a hexagon. How would you be able to tell? Remember the formula? Sum of a five-sided shape is 3 times 180, correct? N minus 2 times 180. What does that add up to? 540, right? So that's where I get this from. So you would have to say, okay, if all of them add up to 540, I have to subtract 1, 2, 3 A's and divide that by 2. Study sheet material, hint, hint, wink, wink, right? I will box this in. And why did I always have the A's up here? Why is that? Because, again, if I go back to this can be found, right? What is this really? This is the interior angle of this whole shape, correct? So they will always be the same. You can find those, right? I just had an idea. Why don't we no, we'll leave it like that. And so in this one, this pentagon here, you have 1, 2, 3 A's, right? It's really the interior angle, but that's what I referred to as AAA. So don't always think it's going to look exactly the same as you just sketched, right? In this case, they're here. But once you find the interior angle of this octagon, so first always zoom out, focus on the shape where these are found inside, find the interior angle, and then you will automatically find these ones that are all the same, because this will only work with regular polygons. Okay, so let's go ahead and do some calculations here using this example. Calculate the values of A, B, and C. Show work, calculations, explanations. And I'm not, as you already realized that I'm not a very artistic person. So we're going to start with a hexagon. That's going to be our first example. So hexagon is actually just two trapezoids put together. That helps me. So I'll do trapezoid like this, and then I just make a copy of it. The nicest hexagon I've ever drawn. Okay, and we will draw a diagonal like this. Draw this in there. I'm not always going to use A, B, and C, but for today I will. I could call X, Y, Z, right? So you got to be able to not fixate on the letters too much, but instead on the process. Focus on the process, okay? And it should say that this is regular, so go ahead and do this. Outside of this hexagon, you go ahead and make sure they're all the same. All of them have the same side, length, and same angle as well. Okay, so I will tell you this for your notes. Focus on the outside polygon first. It's a hexagon. That means that n is equal to 6. Find the interior angle. Interior angle using I is equal to n minus 2 times 180 over n. Okay. That should be your starting point because you have 0 numbers on a polygon, right? Nothing except for, the number of sides, which can give you a lot of information about that shape. So even if I didn't ask you for it, that should still be your first step. So in this case, angle A is going to be the same thing as I, which is going to be 6 minus 2 times 180 divided by 6. And that gives you 4 times 180 divided by 6. That's 120. Very important to us. So I've actually found A already. A is equal to 120. I'm going to make sure that that's stated. To find angle B, what's the shape here created by that diagonal? It's an isosceles triangle, right? So you got to use, to find this angle, let's say on a test this would be x, right? You still know that it's based on this isosceles triangle, so you're actually trying to find this angle right there, okay? So it's 180 minus, it's 180 minus 120 divided by 2. And remember there's brackets there. So it's really 60 divided by 2, which is 30 degrees. Angle B is equal to 30 degrees. I will make a note here. B is the base angle of the isosceles triangle created by the diagonal. So you got AB done. How would you do C? Yeah. A subtract B. Yeah. Yeah. In this case, A here is the interior angle, right? So this whole thing is the interior angle, which in this case happens to be A. So what I will do instead of A subtract B, I will go interior angle minus the one that's above it, right? B we already know, so if you subtract that from the interior, then it works. But Robert, you are right. So the interior angle is 120 degrees at that corner, because remember, at every corner, you have a 120 there. You subtract B, which is 30, and angle C is actually 90 degrees. Let's see. There's a 90 created there at this corner. Okay, so that was one example. How about this? Interior angle minus angle B. That's basically what that's saying. So how can this be applied to a different scenario? I could have done the exact same thing. Watch this. You can tell that I like smart notebook, right? Any chance I have, I'll do this. So let's say I want a heptagon, 7-sided, and I do this to you. the steps will be the same, but the numbers will not, correct? Because what's different for a heptagon? The number of sides, which will change the interior angle, which will change everything else, all right? So you can still apply this to any scenario and still come up with the right answers. You just have to know what needs to be done, right? The steps required to practice that. Okay, let's try another one. We'll do a pentagon. Pentagon, not too bad. So we'll go roof, make it symmetric, and then you kind of go in a bit like that, and then you close it. And this is a regular pentagon. Go ahead. And we will cut it here. So this corner to that corner. And we'll go X here. We'll go Y here. And we'll go Z here. So this is another thing I need to, yeah, go ahead. I'm going to point this out here. You have a triangle here. And what do you have up here? It doesn't look like it, but it's a trapezoid, or it's a four-sided shape. So sometimes you will be like, well, which one should I use? The answer is it shouldn't matter. You should arrive to the same answer. But I'm always going to take the smaller one, the triangle. So n is equal to 5. So angle X is going to be my interior angle, which is 3 times 180 divided by 5. And that is 108. So angle X is 108 degrees. Angle Y. Angle Y is one of the base angles of this triangle. And these two are the same. Because it's an isosceles triangle, the base angles are the same. So I'm going to go 180 minus X divided by 2, which is 180 minus 108 divided by 2, which is 72 divided by 2, which is 36 degrees. So angle Y is 36. Angle X is 108. Angle Z is simply I minus, what would you subtract from I to get Z? Which angle would you subtract from the interior angle? It's like, Y is over here, Mr. Grayson. I can't do it. It's like these two are the same. Okay? So you can just subtract angle Y from it to get that. So it's 108 minus 36, which is 72 degrees. Oops, sorry guys. There you go. And now we're gonna go with an octagon now. Make things a little bit more fun. But before I do that, I always like you to have the bigger picture. So let's say you would have focused in on, you would have cut this out here, and you would have focused on this trapezoid here. It's the four-sided, and you would have used this here, 360 minus 2a divided by 2. So I'm just going to have my calculator. I'm not going to actually do that. So that means that z would be 360 minus 2 times a. And a are the two interior angles, which happen to be 108, equals, divide that by 2. You still get 72 for z, right? Regardless of how you approach it, it should be the same. All right, C. Oh boy, octagon. So that's a stop sign, right? So I'm going to go like this. I'm going to start with a trapezoid, then I'm going to go straight down and draw my trapezoid the other way, a copy of the top. Yikes. Okay, so here we will create a pentagon. So this corner here, and I'm going to count 1, 2, 3, 4, and then create that pentagon there. So I'm going to call this X, Y, and wait, there's more. Can you make another diagonal that creates this triangle here? So cut it here so that you have a triangle in this corner. And we're going to call this Z right here. I apologize for that. So you call this sliver here Z. If you want to go arrow in. So if this is Z, then this is also Z, by the way. Okay. Some of you are doing ZZ right now. ZZZZ, right? Wakey. Okay. First and foremost, find the interior angle of the octagon, right? So n is 8. I will just find the interior angle. So it's 8 minus 2 times 180 over 8. And this is 135 degrees. Angle X happens to be the same as angle I, and we'll just say that that's 135 degrees. I hope that doesn't confuse you. It's just saying that way you don't fixate on the letter, right? You're just like, whatever that would have been, right? That is our interior angle, which is 135. Angle Y, which is, it's basically the base angle. This one and this one, they're both Y because they both measure the same thing. You take the outside, that is kind of like the roof. This is your base. So the ones that are on either side of the base, those are the ones that are the same. So to get Y, we would go 540. Where did I get 540 from? I need you to know where I get 540 from. It's the sum of interior angles for a pentagon, right? Minus, we have 1, 2, 3 angles at the top here that are all the same. And they all measure 135 degrees. Okay, we basically plug this in there. And all of that will be divided by 2. So angle Y is 540. I will do this in steps because I don't want you to get that wrong. Sometimes it's all beautiful. You're showing me the work and everything, but then you type it in wrong. Right? So I'll do the top first and then divide that by 2. That's 67.5 degrees. Angle Y is 67.5 degrees. This is your isosceles pentagon. You realize that you actually have 2 isosceles pentagon, like that cuts it in half. Right? But I focused on this one because that's where the letters were. And then I have to find Z. Z is found inside an isosceles triangle. So I have to go 180 minus the one interior angle here. This is the same all throughout the whole octagon. So that is 135. Divide that by 2. So that would be 45 divided by 2, which is 22.5 degrees. Angle Z is 22.5 degrees. And now I want you to try one on your own. Take that booklet with the worksheets. Page 14 and 15. For now, just do one, okay? I want you to do this one here. And then I'm going to go over it before we go, okay? Get your feet wet though right now and try that one. I added page 23 to the questions that you should be doing. So make sure that's on there.